Hello everyone, today I introduce microservices. The software life cycle has three components: analysis, plan and design, development, testing, release, the monitor. With the analysis, we will gather requirements. The goal of the analysis is to determine where problem and extend to fit the system. Plan and design. Plan bring to meet requirement in the given time. Operate and design to detail including business rule, process diagram, the above of the state with describe the new system at the college of the model or the subsystem. Development, the real code with right here. The team develop can implement the requirement of the business. Testing or the pipelines is brought together into specific testing environment. Then the checklist for error, bug, and interoperability. Release, putting release into production. Monitor, doing health checks, checking time for request and response. What is a microservice? The microservice architecture style is an approach to develop the single application as a series of smaller services. It's running in its own process and communicates with the likewise machines. Microservices are small and autonomous services that work together. Building the microservice the same the new main. There are no specific technology used in the build the microservices. Some principles and architecture patterns are used to build the microservices. Microservices overview. Big or small, who design. E is the number of slides in the course. E is the number of development in the team. There is not universal manager. One microservice should do one thing and do it well. It is microservice because of the scope of the functionality, not line of code. Subdomain should be identified to count the scope of the functionality. Bounded context is very important, should be built around the business capability. The service is the identity dislike component for the body context. Interoperability, use the message-based communication independent from the technologies. Simply is SOR. Monolithic application. The simply a monolithic application consists of the model, the single database. User interface API can be exposed for third party. You can have more than one engine running behind load balancer. You can see the model of the monolithic application. We have the one database and one application. The front end code one application and one database. Monolithic application has brought simple to build, simple to test, deploy to scale, multiple intent, simple to develop, limited to one language. The con of the monolithic application: the bigger the app, the bigger the team. New team member productivity is low. Costs harder to understand and modify. Not updates with the new technology. Startup of the app will take a long time. Scale for the better reason. Need more CPU for calculating invoice. You will scale the all up. Taking the monolithic app and dividing it to smaller services with little, concentrating on something smaller. So voice lifecycle is still the same but smoother faster. Smaller team, smaller service, with life side by side. Moving to the microservice. Microservices should be the main drive design. Taking the monolithic application and moving to domain-driven design. Domain e-commerce, subdomain user auto type, profile address to order, invoice account, subdomain product the supplier. Dependency, subdomains should be totally independent. If you find any dependent duplicate entities, it required. This is the diagram, the model of the microservices. You had three the service with three database. For example, you can see the service 1 had the user and address. The service 2 had the user's orders, invoice and product. The service 3 we had the product category, the supplier. The front end can call to three services to get information and add or update the info to database. Moving to the microservices. About the organization, team will be divided by the subdomain, not domain. Right side team for each subdomain. Each team will be solely responsible for their final product. Each team should be independent, but the communication between them should be handled by the management. Each team should have their own responsible. The data store. Each microservices should be has its own database. For example, the product relation to database. With the service order, we will use the non-SQL. With the service user, you can use the database LDAP. What problem? If user change his thread, it should be redirected to the entity found in the order subdomain. In microservices, which there is no distributed transaction. In the same transaction, you update 10 table in different database. Due to performance issue, Therefore, data is not immediately consistent. Data store solution for the database data scene either using chain data the capital or the event to scene button. Both are the always of the modeling data is basically SQL using the combination of the multiple database service publish the event when the data chain and the other service will consume the event and update the data. Kafka can be used for the keeping the data easy. About the UI, the component button can use to the consistent client side and the server side. Communicate between the service with the service. Remote producer invoice and can NBC. The communicant to the service orders and product request release reasonable website request product right can be seen. We will use REST or the SRIB can be used. When you add the button event to scene. For example, head to the service users order and product. The message auth event on brokers or the channel. Microservice can publish the event and the microservice who init can supply to broker and receive the message at a later time. We use the Kafka to apply the button for the microservices. Communication using any to the method unit protocol format is sent with JSON or the XML, readable and easy to implement. Binary with NRBC more complex. Microservice needs context to know the API of the other microservice. Example, to use SDL and so what you find. Distributed service. Microservice deploy when the network location and change the dynamics. The question: how can the microservice communicate with each other when they are the location or change dynamically? The service registry. Distributed service. The service registry is the phone books of the service. Microservice should register when the cell on startup and at the shutdown. Best way for front-end to call the microservice is booting an API gateway. For example, when the front-end call the API to the API gateway will control the request from the frontend to the service and get data from that service to return for frontend. Best way for frontend to call the microservice is putting an API gateway interface interface can control the growth, the cutting fundamentality, the authentication, the authorization, read the API transaction, security, yield identify and access management for authentication and authorization. One single an access token can be used to move from the microservice to another. Scalability. You can scale one microservice and more. Scaling can be we scale to the vertical, adding more the power to existing the machine for CPU, RAM, or scale for the horizontal. Dedicate more the machine the several intent. Client load balancing with choice from the registry using rules around the road bin, for example. Availability. Mainnet is up and operational. We had in their architecture some the single point on the failure. Brokers, API gateway, registry. Outbound should be scaled horizontal. Multiple intent and clusters to be seen. Monitor in microservice should be centralized. You log aggregation log state can be used. You be visible in the dashboard. Blur Kibana can be used. Health checks. The service running can handle requests. You should database structures available space. Record exception in the tracker system. Citable. Weather status. Drop window can be used. Limit traffic to defend attack. A correlation ID, transaction ID for the journey of the request double can be used. About development microservices can be on the physical or the virtual server. Still, the physical bus can control the CPU or RAM. Microservice should be the package with its dependency in the container image and develop it as a container. Image can be easily moved from one environment to another. Docker to be used. Kubernetes is used to orchestrate the container. The Jenkins is used to continue delivery. There should be internal configuration for this environment. Putting the most in depth environment only. Extracting the new functionality throughout the configuration. What the challenge when applied the microservices? About the business concern. Interaction between teams is difficult. Many training need to be done at the different depth stacks. There is no standards in microservices. Solution will release on some standards HTTP SQL, but not standard stack. There is not a single framework, but there is integration of different technology, not a single support. About cost, small team, cheap start, cheap deployment on cloud, with timing faster to the market. The technical concern, design, how to partition the system to the service, invoice cost being the service, how smart technical diversity, choose programming language, write database, distribution, communication over the network, how to deal the network failure, resource recur, data store, the data per subdomain, keep the data easy, security, access token, revenue. About the testing, let's go view based statistics. Test in insulation, integration testing is hard. Maintain natural. Let's go to maintain. Let's go to understand. Extensibilities, new feature, new microservice. When to use microservices? When you time to the market very fast, you can reach visibility. When you want to scalable, very easy. Thank you for listening.